Hi, this is Bill the Techno Gypsy. In this video, I'm going to show you a simple modification that I did to my Cinetics Lynx Slider to make it more useful in my video environment. One of the things I found when I first bought the Lynx Slider was that it came with the 2-foot extension tubes, which were aluminum, and those worked fairly well, but it didn't give me the movement length that I needed. So I purchased the 4-foot carbon fiber rods, and I got into a problem that when I would set this thing out, I would get torsional flexing between the two carbon rods. That's really not a problem on a smaller camera. The Cinetics motor system here is designed to support a camera weight of up to 5 pounds. I ran into issues because I found that even with my 5D Mark IV, I had to remove the external battery pack and just basically cut it down to a smaller size. If you're running a mirrorless camera and some of the newer cameras, you shouldn't have a problem at all with the weight as the standard weight on this. But as an example, this is my Blackmagic Pocket Camera 4K with the V-mount battery that I had to put on it, the follow focus, all the rest of the cage. This guy comes in at about 9.5 pounds, which exceeds the weight as it's stated from the factory on the slider, and it will cause these carbon fiber rods to bend. So I just got into working with 80/20 aluminum. Basically, it is an erector set for an adult, and all I did was I designed out this support system, cut it, and put it together. And that's what I'm going to show you in this video. I also had to 3D print 4 blocks that I had to use as spacers to raise it off of the base here to keep this thing level. This center point right here is about 0.8 of an inch taller than the bottoms of these other 4 points. So let's get into this, and I will show you how I put together the 80/20 aluminum. Now I'm going to show you in greater detail how I built the reinforcement frame for my Cinetics slider. The first thing is, on the outer perimeter of the slider, you can tell over here that I reinforced each of the 4 corners. Now, these reinforcement pieces are simple brackets on angle brackets that have 2 screw hole openings on each of the sides. They lock the 80/20 aluminum in place, and it's not going anywhere. Now, the way that they're locked in place is through the use of a captive screw mechanism. This is a hex nut bolt, and it goes into the slider plate on a nut here. You put the slider plate into the 80/20 aluminum, you tighten it down, and it locks 80/20 in place. Now, on the internal elements, I used 2 of these smaller angle brackets. These have a single screw hole each. Put 1 on each side, and that center element is completely locked into place. Now, one of the things I had to do getting into this was that for this center piece, it's 0.8 of an inch taller than this piece and the other 2 on the other end. So I had to find a way to balance it. So what I ended up doing is I came in here. Get a better shot here. These are 3D printed blocks that I did that are 0.8 of an inch thick with a 3/8 inch hole in the middle of them, and they allow me to balance from this on the center piece that you can see how much taller it is, and this balances each one of the other elements to get them at the proper height. You can see over here that I mounted a Manfrotto tripod plate. Now, right now, this is set for how I was doing the demonstration here, but when I use this, I only have 1 screw in here, and the plate goes this way. That allows this whole unit to lift up and down versus tilting from side to side. I also put on the 4 feet. Those are with a captive bolt and a nut. And it became very simple to put this whole system together. the center controller here, I took a spare piece of 80/20, mounted it vertically, used 2 angle brackets to hold it into place, and it completely locks the control head module in place. So overall, this is the way I built the whole system up. And I built the reinforced frame so that with the frame, now the distances between each one of the bars is only 1 foot. And there's no tension or bend or anything else that occurs in here on this slider. So now it is workable for heavier load. And even for my 5D Mark IV, it works out beautifully. But the nice thing here is that it completely stabilizes this frame and makes it a very, very usable piece of video gear. Now that we've looked at how I put this frame together, I'm going to show you some of the other capabilities or aspects of this system. Now, one of the things to understand is that for this video, I turned the Manfrotto mounting plates on the tripod plates here vertically. This allowed me to be able to tilt this from side to side, which you wouldn't do in normal use. All I do is take the screw, loosen it here, put these back out at 90 degrees, and it gives me the capability to lift each end and to fully maximize the use of the slider. One of the other things is that this motor unit here weighs approximately 6 pounds. I did do some experiments playing around with this where I took my 1DX Mark II along with the Crane 3 gimbal. I removed this motor mount system and put the gimbal, mounted it onto the slider plate here, and this thing functioned without a problem. Now that complete rig comes in at a little over 16 pounds. So the motors that are put in to this system are very capable motors. And who knows, as I move on downstream, I may actually go ahead and utilize the controller and the motors, expand this out to a wider size and put in metal tubes up here along the top and actually spread it out and make this into a more of a professional slider that can be used in a production environment. So I hope you've enjoyed this video and found it useful and interesting. I hope you look at subscribing to my channel and at least give me a thumbs up because that helps the algorithm. This is Bill, the Techno Gypsy, saying 7-3, and God bless.